Hello everyone. In this video, I will discuss the first question in the homework 5. Now let's first see the problem. We are given that x and y are independent with little fx equals ux minus 1 minus ux minus 2 and little fy equals uy minus uy minus 1. And the bigger z equals bigger x plus bigger y. We need to find the little fz. The first method is convolution method. That is, we calculate the little fz by indefinite integral that f little fx alpha times little fy z minus alpha d alpha. And we know that little fx equals 1 if x is greater or equal to 1 and less than and equal to 2. While little fy equals 1 if y is greater than 0 and less than 1. We know that little fz equals the indefinite integral that u alpha minus 1 minus u alpha minus 2 times u z minus alpha minus u z minus alpha minus 1 d alpha. And when alpha is greater than 1 and less than 2, the u alpha minus 1 minus u alpha minus 2 equals 1. And when z is greater than alpha and less than alpha plus 1, that u z minus alpha minus u z minus alpha minus 1 equals 1. And it's easy to know that the little fz equals z minus 1 if z is greater than 1 and less than 2. And it equals 3 minus z if z is greater than 2 and less than 3. And it equals 0 if otherwise. The second method is geometric method. We will use x and y and the big fz, since little fz equals d big fz over dz. And we know in the graph that the big fz equals the area of shadow, and if z is in the lower triangle of the square, z is greater than 1 and less than 2. And the shadow is a triangle. The area equals half z minus 1 times z minus 1. And the little fz equals d big fz or dz equals z minus 1. If z is in the upper triangle of the square, which means z is greater than 2 and less than 3, the area of shadow equals the area of square minus the area of the upper triangle, and it equals 1 minus half of 2 minus z minus 1 square, and little fz equals d big fz over dz, and it equals 3 minus z, which is correspondent with the result in the first method.